Now we have established that the lines in each atomic emission spectra correspond to some energy level. What does that mean? What is that related to? It turns out it's descriptive of energy levels of electrons in atoms. So imagine we have a y-axis that's energy. And there are discrete levels of energy associated with an element. For example, there's 4 here, 1, 2, 3, 4, 5. There's 5 in helium. I'll put another one there. So maybe this is the helium atom, and the energy levels go from low to high. So n equals 1 is the lowest energy, n equals 2, n equals 3, n equals 4, n equals 5. And maybe there's some electron sitting in an atom in what we would call orbit. Generally, they occupy the lowest possible energy state. But if that atom absorbs energy, if the atom absorbs energy, this could be electricity, like in a neon light, or a fluorescent light, or it could be like the flame in a flame test. The atom absorbs energy. What happens is electrons in the atom, in their orbits, may go from a lower energy state to a higher energy state. When that source of energy is stopped, and so the electron, well, first of all, let me point out that the electron cannot occupy a state here. That's not possible. It can only occupy an energy level associated with these specific steps. And so there's a change in energy associated going from here up to here. And that change in energy is going to be related to the lines in the spectrum. When that energy source is released or stopped, the electron will drop down to a lower energy state, and when that happens, light is emitted. And we often describe the light, they're called photons, and they're abbreviated h-nu. And the wavelength and energy associated with the released light is going to be equal to the energy difference, in this case from n equals 4 to n equals 1. When energy is absorbed when it goes from a low to high energy, and energy is emitted when it goes from high to low energy.